This next video is about simplifying radicals. Okay, radicals are those square root signs, but they're not always square root. They could be cubed root, fourth root, and so on. But we're going to start with the square root. Simplifying radicals, something like this. Now, when I say to simplify a radical, I do not mean put it into a calculator and give me the decimal form, okay? I could train a monkey to do that. That's not what I want you to do. If you just give me a decimal form for this, you'll just get 0 points every time. I'm wanting you to simplify the radical. And what that means is you're taking out any of the perfect squares that are underneath this radical sign. Okay, so first you got to know what all the perfect squares are. And like I said about the perfect cubes before, there's certain ones that I just think you should have memorized. And I think it's really like the first 13 should be memorized. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6, 7, 8, 9, 10, 11, 12, and 13. These are the first 13 perfect squares. Again, you can always figure them out, but it's just so much easier if you have them memorized. And I honestly believe you all already know 1 through 10. Just 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, blah, 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 all the way down to 11 times 11, 12 times 12, 13 times 13. Now, if you memorize these, then you know what numbers you're looking for, okay? These are the numbers that we're trying to get out of that radical sign. So if the number I give you that's under the radical sign has one of these as a factor, you have to factor it out, okay? This is a very important list. Later, when I get to our perfect cubes, those were 1 times 1 times 1, 8, 2 times 2 times 2, 27, 3 times 3 times 3, 64, 4 cubed, 125, 5 cubed. Those are the perfect cubes that are just going to make your life easier if you know them. Okay, so getting back to the simplifying square root of 48. I said you have to get out the radicals. Okay, there's several perfect squares in here. You have to get out the perfect squares I meant. There's several perfect squares. 4 is in here. 4 times 12 is 48. 16 is in here. 16 times 3 is 48. That's it. That's the 2 perfect squares that are in here. You want to get out the biggest perfect square. So there's going to be more than one way to do this problem. Okay. So what you're going to do is you're going to break this number down into its prime factors. You're going to go back in your brain to probably about 6th grade and you're going to make a factor tree. Okay. 48 is, you can do 6 times 8. That's fine. You can do whatever number you want to. 12 times 4, 6 times 8, 16 times 3. It doesn't matter. Then your 6, you're going to break that down into 2 times 3. Your 8, you're going to break that down into 2 times 4. And then your 4, you're going to break up further into 2 times 2. So 6 times 8, 6 became 2 times 3, 8 became 2 times 4, 4 became 2 times 2. This is the prime factorization. 2 times 3 times 2 times 2 times 2. Let's bring in all those factors down here. That means in a square, you need 2 things to take it out of the radical. Okay, here's what I mean. 2 squared, square rooted, goes back to 2 again. Okay, think about this. 2 squared, square rooted. 2 squared is 4, square root of 4 is 2. So that just goes back to 2. 3 squared, square rooted. 3 squared is 9, square root of 3, or square root of 9 is 3. 4 squared, square rooted. 4 squared is 16, square root of 16 is 4. You see what's happening. The square and the square root are going to cancel each other out. And when you're talking about a square, you need 2 of them. Okay? So for every 2 of these, a 2 is going to come out. Okay? Cross off those 2, cross off those 2. For each of those, a 2 is going to come out. So that means that I have a 2, another 2, and a 3. These 2 2's became 4. You square rooted them, came back to 2. These 2 2's became 4. You square rooted them, they came back to 2. This final answer, 4 times the square root of 3. Okay, now that probably wasn't the best explanation, so let me show you a different set of numbers. I would have never done 6 times 8 to do that, but it's okay if you do. I'm going to do it differently though. There's always more than one way to do something. I'm going to take my 6 and my 8, and I'm going to break it up like this instead. Okay? With my 6, I'm going to leave it alone. Here's why. 6 does not have a perfect square in it. 6 is 2 times 3, and neither 2 or 3 were in that list. 8, however, has a 4 in it. 4 is a perfect square. So I'm going to do this. I'm going to break that 8 up into 4 times 2. Square root of 8 becomes the square root of 4 times the square root of 2. Now, the square root of 4 is 2, so I can cross that off and make it a 2. Okay? Now, I said I was going to leave this one alone, but since I have this square root of 2 here hanging out, I need another square root of 2 in order to make it come out of the radical. So I am going to break up my 6 into 3 times 2. So my square root of 6 becomes square root of 3 times square root of 2. Then I have this square root of 2 that I still had. And then I have this 2 that already got out. It's like they're in jail and they need to come out of jail. Being under the radical sign is in jail. I'm trying to get them out of jail. I broke this 2 out by taking the square root of 4. Now I'm going to break another 2 out because 2 square roots of 2 become 2. Because this is square root of 2 times square root of 2, which is square root of 4, which is 2. Those 2 cancel to become 2. Finally, this 2 and this 2 can be multiplied to become 4, and the answer is 4 square root of 3. Same thing I got last time, but it's a different way. Now, I'm going to show you another way. Instead of 6 times 8 is probably everybody's like obvious, but what if I did 12 times 4 instead? If I did this is already 2, so I can already get that out right away. This has a 4 in it. So I'm going to break that out and break up my 12 into 4 times 3, and then I have my other 4. Okay, now when I'm thinking about this, I could either just do this right away. Square root of 4 times square root of 4 is 4, because square root of 4 times square root of 4 is 16, which is 4. Just cancel those 2 together. You need 2 of them to get out, so 2 of those together make 4. You could have done that. Same answer as before, or I could have said square root of 4 is 2, square root of 4 is 2, and then 2 times 2 is 4. Okay, let's try a different number besides 48. There are definitely direct routes to the answer, and then there are indirect routes. 72 is our next one. Okay, I could do 9 times 8. 8 times 9 is 72. That's probably most people's first choice. And 9 is a perfect square, so that's cool. I can already take this 9 and cross it off and become a 3. But I'm not done. Why? Because 3 square root of 8 is not reduced all the way because square root of 8 has a 4 in it, and that 4 desperately needs to get out of jail. That 4 does not want to stay in there. So what I can do is I can rewrite this as 3 square root of 4 square root of 2. My 3 already got out. It's safe. It can just hang out here. My square root of 8 becomes square root of 4 times square root of 2. Now I can break out the 2 from here. Square root of 4 is 2. Multiply 3 times 2 is 6. Square root of 2 is my final answer. Just double check. There's no perfect squares in 2, so I'm good. I know that's my answer. We're going to double check it a different way. A little less obvious way, 72 is 36 times 2. 36 times 2. Guess what? Square root of 36 is 6. That breaks out immediately. One step and I'm done. Voila. Same answer. Got there faster. Doesn't matter though. Use whatever factors you feel most comfortable. At the end of the day, you just need to be able to break it down fully. Okay, let's try something where you've got more than, let's say more than 2. I mean, more than 1. Okay, if I want you to simplify this, there's 2 ways you could do it. You could either break this apart and see if it has anything that can go with this, although 12 doesn't have a 5 in it. 12 would be 4 times 3 and then 5, and then I could break out the 4. Let's go ahead and do that. This would be 4 times 3, and then I still had my 5. Then this square root of 4 becomes 2. And then I put these two back together. There's no perfect squares in 3, there's no perfect squares in 5, so I put them back together and get 15, and there's no perfect squares in 15. Done. 2 times the square root of 15. I also could have put these together. 12 times 5 is 60. And then if you recognize that 60 is 15 times 4, then you could do 15 times 4. And then square root of 4 is 2. Voila, same answer. Maybe you put it together to become square root of 16, and then you decided to break it up into 6 and 10, and you went, oh, dang it, I don't see any perfect squares. There's no perfect square here. There's no perfect square here. There's no perfect square in 6 or in 10, but you know what is? 2 is in both of them. So if I take this out and become square root of 3 times square root of 2, and then I make the 10 square root of 2 times square root of 5, guess what? These two square roots of 2 come out to become a 2. And then these two can go back together and become the square root of 15. And voila, I am done. But I'm not done with the video because I still have to show you how to do things if you've got variables in them. Now, I know this is getting a little bit long, and I could certainly decide to make a different one, but I'm just going to go ahead and make less videos and make them a little bit bigger, a little bit longer. Okay, how about this? Now, the square root of 4 is 2, so that's fine. I could just take that out and be done with it. This is where it gets a little more complicated. I didn't mean to make these all x's because that's really not that complicated, although let me just continue with this problem. Here, what I could do is add these exponents all together. I'm going to take out my 2, and then I'm going to rewrite this as x to the 18th. Okay? I just added these all up, exponents. Now, 18 has a 9 in it. So what you're trying to do here is you actually divide this by 2. I know that seems weird because division by 2 is not what a radical sign means, but I want you to think about your powers of exponents. X to the 18 means 18 x's, okay? If I have this, which the whole thing is just square roots. So if I have that, it's going to come out to be a regular x. X squared square rooted is x. So you're really trying to think of how many of these groups are in here, okay? X to the 18th is really x squared 9 times. Okay, you could have thought of this as this as x squared times x squared, and then x becomes x to the 6th, and then x to the 8th. There's several different ways you could do this, but if you think about it like this, each of these x squareds comes out to be an x. X squared square rooted is x. Cross it off, bring it out. Okay, x squared square rooted is x. Cross it off, bring it out. And so on and so on and so on. If you think about this, when I started with 18, I'm going to have 9 groups of 2. 9 groups of 2 all coming out means this will end up with 9 x's on the outside. So this answer simplifies to 2x to the 9th. Okay, the 2 came out of the 4, and this all added up to 18, so that meant 2 groups of 9 to come out. All right, let's try it with different variables. What if this time I had 16x to the 4th, y to the 5th, z to the 10th? Okay, let's go one at a time. Square root of 16 is 4. I can just bring it on out. Square root of x to the 4th. That's 2 groups. That's x squared, x squared. Each of those groups will come out and bring an x. So this becomes x squared. Notice that I really just divided the 4 by 2. This, we're going to draw this one out. 1, 2, 3, 4, 5. Okay? These 2 come out and become a y. These 2 come out and become another y. This one doesn't have anything to come out with. This one gets stuck underneath the radical sign. It doesn't have a pair. It has to stay there. So I'm going to leave it under here. But the other two I took out, okay? Now, using your rules that we've been talking about here, if I just divide this by 2, I get 5. So what is now on the outside is 4x squared y to the second, and then it'll become z to the fifth. And then I still had that one y that had to hang out underneath because that one y didn't have anything to go with. All right, let me do another one like that. Only I'm going to do square root of 32x to the fourth, y to the sixth, z to the 12th. 32. 32 is 8 times 4, so I'm going to go 8 and 4. Then I'm going to bring my 8 into 2 and 4. Okay, notice 32 became 8 times 4, 8 became 2 times 4, and then the other 4, these two 4s together will become a 4 on the outside. So far I have a square root of 2 stuck and staying on the inside, okay? Next, since this is a power of 2 and these are all even, I really just have to divide them. I'm thinking about how many groups of 2. How many groups of 2 are in 4? 2 of them. This becomes x squared on the outside. How many groups of 3? 3 of. How many groups of 2 I meant? 3 of them. This becomes on the outside. How many groups of 2? 6 of them. That goes on the outside. All that was left under here was my little lonely 2. Now, look, what happens if my power isn't a square root? Let's do a cubed root. Cubed root of x to the 12th, y to the 5th, and z to the 14th. This time you're looking for groups of 3 because x to the first, x to the first, x to the first, x to the third cubed root is going to take it out and become an x. So now you have to divide these by 3. This is going to become x to the fourth on the outside. Now with your y to the fifth, let's draw this out. Y to the fifth means this. It takes 3 of them to get out this time because I have a cubed root. So 3 of them come out and become a y. Those 3 come out and become a regular y. These 2 are stuck under the radical, so I put them back as a y squared. 14, okay, think of it as groups of 3, so I'm going to write it as z to the third, that's 6, z to the third, that's 9, z to the third, that's 12, z to the second, that's 14. 3, 6, 9, 12, 13, 14, that's what I have. It needs 3 of them to get out. So z, 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 z. Those will all come out as z's. So there's 4 z's on the outside. And there's z squared left over on the inside. So you just have to practice. If this was a 4, you would be putting these into groups of 4 to come out, and then whatever's left has to stay in. So it's just a matter of practicing it and getting used to these different numbers. But it's really not that hard. I actually have fun with it. I enjoy it, and I hope you do too. There you go.